Hello, welcome again. So, in last lecture, what we have studied is some introduction of small signal analysis for the BJT. Right? To start with small signal analysis, first we need to understand the characteristics. Right? And intentionally, I have chosen common emitter configuration. I told you the benefits that if it is common emitter configuration, then if I compare it with the common base and common collector, then current gain is generally high. Look at this current gain and voltage gain is high as if I compare them with common base and common collector configuration, and that's why it is always preferred common emitter configuration. Alright, so let us start with the characteristics of common emitter configuration. See, the characteristics of common emitter configuration means I am talking about the input and output characteristics, what we call it as IO characteristics. I means input, O means output. So those are output characteristics that I'm talking about, is it? Now, input characteristics means what? Look at this. If it is input characteristics, let me write here. If it is input characteristics, then it is a graph of input voltage versus input current, is it not? Or I can say here I will have input voltage versus input current, and output characteristics means what? Output characteristics means a graph of output voltage. Look at this is output voltage and this is output current. So one can clearly understand, if it is input characteristics, then a graph of input voltage versus input current, and if it is output characteristics, it is a graph of output voltage versus output current. Now we are using common emitter configuration. Look at this, we are using common emitter configuration. If it is common emitter configuration, then emitter terminal must be common. Yes, it is common. Emitter terminal is common, and input is provided to the base. This is what my input, and we take output at the collector. So base is at the input side and collector is at the output side. Then input voltage, look at this. If I say this is Vin, what is input voltage? That is voltage provided between base to emitter. That is input voltage. Input voltage means what? VBE. And what is output voltage? VO. Output voltage is a voltage taken from collector to emitter. That is not. So output voltage will be VCE. That is what? Collector to emitter. Now input current, IN. What is input current? The current which is flowing through the base. That means it is IB. So input current is IB. What is output current? The current which is flowing through the output terminal. That means collector. That is IC. So IO is nothing but my IC. So now what will be the input and output characteristics then? See, input characteristics for common emitter configuration. Input characteristics for common emitter configuration. It is input voltage, means it is VBE, versus input current, that is IB. Then output characteristics. Output voltage, it means it is VCE, and output current, that is IC. So input characteristics means a graph of IB versus VB, and output characteristics means graph of IC versus VCE. So it means now I will have this thing, VBE versus IB, and output characteristics means VCE versus IC. That's what. Now, no matter what the graph is it? No matter what the graph is, whether it is like this or whether it is like that. Is it? I don't know what will be the graphs yet, but one thing I conclude: input characteristics means IB versus VB, output characteristics means IC versus VC. Now, let us start with what will be there in the graph. How the graph will be there. That's what we have to discuss now. Now, as we are going to have those graphs, let us start with practical approach. Is it? It means connect the common emitter circuit on the breadboard, use a function generator, use a power supply, use a CRO, connect everything, and then let us measure the input current, input voltage, output current, output voltage, and let us draw the characteristics. Is it? So let me draw the circuit diagram by which I can have those graphs of input and output characteristics. Now, okay, let me draw the circuit here itself. This is what? A small resistance which is connected to the base. This is a meter by which I am going to measure a base current. And now this is what my base. This is collector, this is emitter. Emitter is grounded? Yes, emitter is grounded. Now, from the collector, again, to measure a collector current, I will connect one ammeter. Then, a small collector resistor that I need to connect because the battery cannot be connected directly. And then, I will connect a collector voltage here. Why I am connecting this collector voltage, where I am calling it as an VCC, because this is a biasing voltage. Hope you remember that. Obviously the biasing voltage must be there to the base. Emitter is common, so let me connect everything to the emitter, that is two terminals of the batteries to the emitter. So this will show me IB. Now I am using small letters. Instead of capital B, I am using small b. This ammeter will show me IC, or instead let's use everything small because now we are in characteristics, na? So why to use? Now this is IB and this is IC. Call this resistor as RB, call this resistor as RC. This voltage supply at the collector, I am referring it as an VCC. One voltage supply is also there at the base. Let me call it as VBB. So IB, IC, output current, input current, we have defined. This is emitter terminal, this is base terminal, and this is collector terminal. One transistor I have taken. Now a voltage I need to measure from base to emitter. This voltage, let me draw a voltage symbol. What is this voltage? It is voltage across base to emitter, right? That is input voltage. Now again I have to measure output voltage also, so let me draw another voltmeter at the output side and I will call it as collector to emitter voltage. See, this is a practical setup by which I can evaluate the input and output characteristics for the common emitter configuration. Is it a common emitter configuration? Emitter is grounded. Look at this, because of this VBB supply, a positive voltage gone to the base. Because of this VCC, positive voltage gone to the collector. So transistor is properly biased in an active region. One junction is forward bias, another junction is reverse bias. Yes, it is done. So four parameters, that is input current, input voltage, output current, output voltage, four parameters are there. So now let us start with characteristics. So first we will start with input characteristics. Input characteristics. What do you mean by that input characteristics? It is a graph of input voltage versus input current. So voltage is there on x-axis, that is VBE, and this is IB. Just check whether we have used the same notations. No, we have used VBE. B is capital, and even VC we kept capital. I don't want this. Let me erase them, and let me use the small notations, okay, because I don't want any confusion. So this is VBE and this is VCE. Now it's quite okay. So IB versus VBE is the input characteristics. So as if now we are in input characteristics, output has a role in this, output current or output voltage. See, they have no role at all because we are in input part, input current and input voltage. That's what the things I need to deal with. Then output current and output voltage has no role for the time being. So if they don't have any role, what to do with them? That what we will do, we will keep this output voltage. Output voltage means what? VCE. That VCE we will keep it as a constant, because when VCE is constant, obviously IC will not change. How to keep VCE constant? How to keep this VCE constant? Look at this, VCE is depend on the VCC. So you keep VCC constant to maintain VCE constant, is it? It can be any value, it should be constant. It can be 1, it can be 2, 3, 4, 5, 6, is it? If you are using VCC 12 volt, you can take VCE or you can make VCE constant to 5 volt, 10 volt, no problem at all, is it? So I'm not telling how much value should be there for VCC. I'm just telling that value of VCE should be constant if I'm checking input characteristics, is it? Now let us discuss this input characteristics with one proper example. Proper example means assume that I have connected VCC is equals to 12 volt, and this battery VBB also I have connected as a 12 volt. This RB, one resistor that I have connected, if it is 1 kilo ohm, and this RE is 100 ohm. Now this is what actual practical circuit. The BJT that I am using, use a simple general purpose transistor, that is BC547. You remember that black package, is it? A black body transistor with 3 terminals. This is what generally available. So many transistors are available in our lab, is it? अगर आप लैब में देखो तो इधर उधर पड़े रहेंगे आपको BC547, general purpose, very cheap transistor I'm using for taking the characteristics. Now VCC and VBB are 12 volt. Yes, it is. One resistor RB is 1 kilo ohm, RC 100 ohm only I have connected. So by proper example we'll understand the characteristics, input as well as output also. Now so first thing is IB versus VBE when VCE is constant. VCE has to be constant. Then how much VCE should be? Let me keep VCE is equals to 3 volt. It should be constant, so keep it 3 volt. How to make VCE constant? Obviously by adjusting VCC. It means what you have to do at the time of practical, you change this VCC. You start changing this VCC until this multimeter which is connected as VCE shows 3 volt. Is it? So what do you have to do? You have to change VCC until this multimeter, that is VCE, this multimeter shows 3 volt. If it shows 3 volt, stop changing VCC. It means I have adjusted VCE is equals to 3 volt by adjusting VCC or by changing the battery VCC. Is it? तो क्या करना है, हमें पहले VCC को ऐसे चेंज करना है जब तक VCE 3 volt सेट नहीं होता. And it's not mandatory that you have to keep 3 volt only. You can adjust. For example, you are working in groups. One group can adjust VCE is equals to 3 volt. Another group will adjust their VCE to 5 volt. No problem at all. It must be constant. Is it? I'm not restricting to the value. Constant is the motto. Now, if I made this VCE constant, then don't touch output part, because we want input characteristics. We have nothing to do with output part. So keep output part constant, that is VCE constant, and then move towards the input part. So when we move towards the input part, What is my job? I want to measure IB and VBE. So the graph is drawn with the help of observation table. So what will be the observation table then? Observation table will have VBE in one column and IB in another column. That's what my observation table is. It means I have to change biasing voltage and measure VBE and IB. Biasing voltage means which voltage I have to change actually. At the input side I have VBB. So compulsory I have to change this VBB. So change VBB and measure VBE and IB. It means at the time of practical you have to change this and measure this as well as this. It means two multimeters are there. One power supply, you are referring it as an VBB. Change this power supply and measure these two multimeters. Write down in the reading. Is it? So let us start with the procedure. Let us change VBB. First, keep this VBB to 0.1 volt. Adjust your power supply for 0.1 volt. Then measure this VBE and IB. Measure means what you have to do. Already you have connected multimeters. Just check what is the number displayed on the multimeter. This multimeter IB displayed some number. Write it here in this column. Is it? If this multimeter VBE showing some number, write it over here. When VBB, this battery shows 0.1 volt. Next reading will be adjust the battery voltage to 0.2 volt. Again measure these two multimeters. Is it? Again change this battery supply VBB to 0.3 volt. Again measure these two multimeters. That's not only procedure you have to do. Is it? This is what input current versus input voltage when output voltage is constant. Look at this. When output voltage is constant. Output voltage means VC. It is constant. Yes, it is constant. This is what my input characteristic. Look at this graph of input current to the input voltage when output voltage is constant. Is it? So like this 0.1, 0.2, 0.3, 0.4 you have to reach up to, look at this 0.5. Measure this, adjust to 0.5, again measure this, adjust this to 0.7, measure this, adjust this to 0.8, measure this, 0.9, maybe 1 volt, 1.1 volt, 1.2 volt, 1.3 volt. Like this you go and increasing the value of VBB, and then you have to note down all the values for these two. That's what you have to do. That's what. This is what input characteristics. So this is input characteristics IB versus VBE when VCE is constant. When VCE is constant. Now when VCE is constant, then let me plot a graph. Okay, let me plot a graph. It's called okay. Let me take a graph. Now what I will do, I will plot a graph of VBE versus IB. It means that will be the graph for this observation table. Okay. And let me tell you what kind of observation you will get. You will get, look at this, what is VBE? Base to emitter voltage. Is it? It is the junction potential. So roughly let me tell you that you will get 0.1, 0.1, 0.2, 0.2. Look at this, you will get here 0.1, 0.2, 0.3, 0.4. Not like a linear increment. Is it? So it means VBB is equals to 0.1, you will never get VBE is equals to 0.1. If you adjust VBB to 0.2, you will never get VBE to 0.2, because some people think that if VBB and VBE, those are parallel voltages. So obviously if I change VBB, in the same proportion VBE will change. But the thing is not like that. What you will get actually, you will get a junction potential, is it? Or I can say, let me rub it first to avoid the confusion. Let me have this. What you will find, let me tell you actually what you will get at the time of practical. You will get 0, 0, 0. Every time you will get 0, and at 0.7, if it is a silicon transistor that we are using, at 0.7 or from 0.69, you will get some increment. Look at this, you will get some increment and you will get a constant voltage. You will get increment and constant voltage. It means at the time of graph, you will get a graph like this. This is a graph of VBE versus IB when VCE is VCE is equals to 3 volt. Is it? Now I can repeat the same process. Let me draw a line. Now I want to repeat the same process. Yes, I will repeat the same process with VCE is equals to 8 volt. Is it? This is one graph of input characteristics when VCE is equals to 3 volt. Now I will follow the same process and I will plot a graph with the same process with another observation table when VCE is equals to 8 volt. It means what here you need to do, again reset the circuit, and again reset the supply VBB, and then now adjust VCE to 8 volt. How you will adjust VCE to 8 volt? Obviously by changing VCC. Change VCC, then you will get VCE adjustment. Again observation table will be there. Here VBB, and then VBE, then IB. Then again change from 0.1, 0.2, 0.3, go up to 1.1. And for every different value of VBB, you have to measure this VBE and IB. Is it? Measure all the values of VBE and IB, and then if you try to plot a graph, then what you will observe? Plot the graph on same XY axis. You will get this. Here, when VCE is equals to 5 volt. Look at this. And those are input characteristics. Those are common emitter input characteristics. Those are common emitter input characteristics. VC is equals to 3 volt, VC is equals to 5 volt or something like this. Right. Now, so input characteristics are done. So let us start then output characteristics. So what is input characteristics? Input voltage versus input current when output voltage is constant. Here, input voltage, input current when output voltage is constant. Now, here, output characteristics. Let me start immediately output characteristics. So output characteristics means it's a graph of output voltage versus output current. It means it is a graph of VCE versus IC. When VC versus RD. We have observed that in input characteristics, this VBE, that is input voltage, is 0.7 and it seems to be a constant value. Why? Because it seems like a junction potential. Is it? It seems like a diode characteristics. You observe those input characteristics. Those are nothing but diode characteristics. Is it? Those are diode characteristics. So this input voltage and input current flows a graph. It shows a graph, and that graph is dependent on output characteristics. Now look at this. In output characteristics, what we have to do, we have to plot IC versus VBE by keeping IB constant. By keeping IB constant. Now, as if I am keeping IB constant, why I am keeping IB constant? Because at the input side I have input current and input voltage. Input voltage, it is a junction potential, so obviously what's the point in changing this? Is it always show the junction potential of diode characteristics. So the option is input current, so I need to keep input current constant. So output characteristics means graph of output voltage and in output current when input current is constant. Is it means now practically what I have to do, I have to keep this IB constant. I have to keep this IB constant. How to keep this IB constant? Obviously by changing this VBB. Adjust this VBB to get desired value of IB. Is it? So let us take an example. Is it? We have to discuss it by example. So in first case, I will keep IB is equals to some 20 microamperes. How to keep this IB 20 microamperes? IB has to be 20 microamperes. It means now change VBB until this multimeter shows 20 microamperes. Is it? Change VBB until this multimeter shows 20 microamperes. That's what we have to do. Now adjust this IB to 20 microamperes, and after that you should not touch the input part. Why? Because we are in output characteristics. We want output current versus output voltage. So input current, once you adjust, then don't touch it. It must be constant. Is it? That's what the thing is. It has to be constant. So when output current and output voltage you are measuring, you should not take care of input current. Is it? You even don't look at the input current what it is, because at the start, at the beginning, we have adjusted to 20 microamperes. Is it? So how to adjust it? By changing VBB. So change VBB, adjust this IB to 20 microamperes. Change the VBB, change that power supply until this multimeter shows 20 microamperes. Once it shows 20 microamperes, then you start your process. Is it? So here observation table should have IC and VCE. See, output voltage and output current. Output voltage, output current. But when I will get variation in output current and output voltage? Obviously, when I vary VCC. Is it? So the same process you have to follow. It means now here you have to change this VCC. Change VCC and measure this IC and VC. See, change VCC to 1 volt, measure this IC and VC. Again, adjust this VC to 2 volt, again measure this IC, VC. Adjust this VCC to 3 volt and measure this IC and VC. It means measure those multimeters what they are showing and write it in observation table. Yes, it is the same thing that we have done in input characteristics. Only we changed VBB as 0.1, 0.2, 0.3, but here it is VCC and we are changing it 1, 2, 3, 4. It is not in point, because we know that VCE, collector to emitter voltage, is generally high, and one thing we know that base to emitter voltage is 0.7, it is less than 1. So that's why go with the smaller steps in case of input characteristics. In output characteristics, go with the higher steps. Is it? So let us adjust VCC to 1 volt and measure these two values. Measure these two multimeter, what they are showing. Whatever the value is, write it here. Adjust VCC to 2 volt and measure this. Adjust it to 3 volt, measure this. 4 volt. Like this you go up to 15 volt, and for every different value of VCC you have to measure IC and VCE. And when you measure the value, then let me plot a graph of output characteristics. No, it's not happening, sorry. Undo is there? Yes, undo is there. Then take this XY. Yes, for every different value of VCE and IC, let me plot a graph. So what is this? It is VCE and this is IC. So this is VCE versus IC when IB is equal to 20 microamperes. And if I plot this observation table here, then what I will get? I will get this graph. IB is equals to 20 microamperes. This is one graph that I can plot. Is it? And it is not mandatory that IB should be 20 microamperes. One can set IB to 30, one can set 40, one can set 50. No matter, if you are working with groups, then it's your choice how much IB should be. Is it? So let me tell you another example. When IB is equals to 80 microamperes. See, I have taken a large difference. Now IB is 80 microamperes, and again follow the same process. VCC, versus, again, it's better to draw a line. It is VCC versus IC again. Now hopefully I can draw the horizontal line. Yes, now it's look better. Now VCC, and this is IC, and this is VCE. For every different value of VCC, we have to measure value of IC and VCE. When IB is equals to 80 microamperes, 4, 5, 6, 7, like this, go up to 15 volt. And for every different value of VCC, measure IC and VCE. And now plot this graph. A graph of IC and VCE when IB is equals to 80 micro. So when IB is equals to 80 micro, and if I plot a graph, the graph will be like this. This is when IB is equals to 80 microamperes, and this is what common emitter output characteristics. Is it? So we have to do it practically. We have to mount this circuit. See, we have to mount this circuit practically. We have to take 1 kilo ohm resistor, we have to take 100 ohm resistor, we have to take BC547, we need to connect 4 multimeters and 2 power supply, and we have to take actual readings of IB, VB, IC, VC by keeping IB and VC constant. We have to obtain a observation table like 1, 2, 3, 4 observation table we will obtain at the time of practical. We will plot the graph of IB, VB and ICVC. So whatever I am telling you, we have to do it practically in our lab. Is it? And you have to plot the graphs on a graph paper at actual graph, the graph of actual observation table that you have taken readings in presence of me, obviously. So those things we have to perform in our lab. Is it? So you remember what is the conclusive discussion? It is an CE characteristics, input and output characteristics. Input characteristics is what? Input current versus input voltage when output voltage is constant. Is it? Input current, input voltage when output voltage is constant. And output characteristics means what? Output current, output voltage when input current is constant. Okay. So this is about the characteristics. This is about the characteristics of a common emitter configuration. Is it? Now, by this characteristics, even I can obtain all H parameters by those characteristics. When we start with actual hybrid and H parameters, then again I will tell you that how can I obtain the the parameters by using it. Is it? So we will stop here. Probably from next lecture we will start with actual analysis. Thanks a lot then.